Good morning, everyone. My name is Paphinvit Hartono, and today I would like to present you about solar power plants. A solar power plant power generation system is a system that converts sunlight into electricity. The two main types of solar power plants are photovoltaic (PV) solar power plants and concentrated solar power plants (CSP). The first one uses arrays of solar panels to convert sunlight directly into DC electricity, whereas the second option uses mirrors or lenses to concentrate sunlight onto a receiver, which then makes use of the heat to produce steam and generate electricity with the turbine. For the scope of today's presentation, we will dive deeper into the second option, which is the concentrated solar power, as it will relate with the topic on thermodynamics. To begin with, this is what a CSP energy generation diagram looks like. It is divided into two different sections, the solar field and the Rankine power block. Starting from the left side, the heat is captured in the receiver. The fluid that is used in CSP plants is called heat transfer fluid, or simplified as HTF. It has high thermal conductivity and specific heat capacity so that it can retain a lot of heat and keep it for a long period of time, allowing the plant to continue to generate electricity even when the sun is not present. An example is synthetic oils and molten salt. Furthermore, they are also non-toxic and non-flammable, making it a superior choice, as it is safe and an environmentally friendly option. Moving on, after the fluid has absorbed the heat from sunlight at the receiver, it will channel through a heat exchanger and exchange heat in the heat exchanger with a primary working fluid. The primary working fluid is present on the right side of the diagram, but it has similar heat-carrying characteristics like its counterpart, where fluids with high heat capacity are more desired for storage and efficiency purposes. But for this case, our primary working fluid will be water, because water is a common option as it is readily available. Moving on to the right side of the power plant, it is the Rankine block system. The first process is the heating of water to generate steam at constant pressure. The second process is the expansion of the steam in the turbine, during which steam does work and its internal energy is converted into mechanical energy. The third process, going down, is the condensation of steam back to water at constant pressure, which releases the latent heat of vaporization. And finally, the fourth process is going back to the heat exchanger, where the compression of the condensate happens. However, this certainly is just a simple representation of a concentrated solar power plant system. In the real world, big energy companies such as Siemens Energy AG have a more intricate setup to make the process output more efficient. And it looks something like this. If you notice, there are several changes to the one that we know previously, specifically these three main parts. First, we notice that that it absorbs heat from sunlight using heliostats directed on a central receiver tower. The great thing about this is that this avoids the potential heat loss from the transfer through the pipe, and also avoid unnecessary waste of space putting the pipes. Second, we also noticed that there are also storage systems that houses excess heated and cooled working fluid that makes it possible for the power plant to continue producing even when the sun is not present, maximizing its output. Finally, we also noticed that the company of the Siemens CSP has also added superheating and reheating element in the power plant vapor cycle system. Just a brief background. The superheating is the process of increasing the temperature of the steam above the temperature it changes from liquid to gas. By increasing the temperature of the stream or steam, superheating reduces moisture content in it, and this prevents erosion and corrosion in the turbine. In this process, there is also reheating, and it is the process used in multi-stage turbine, where reheating the system helps it to regain heat that it loses when it passes through a turbine. Because when passing through a turbine and expanding, there's a potential for the heat to lose and to condense. So reheating helps it maintain its heat content for the remaining of the turbines, ensuring that its work is maximum for the remaining stages of the turbines. Nonetheless, these are some of the ways how Siemens CSP is able to improve the output efficiency of their solar power plant system. Here are my references I used to make this presentation, and that is all I have for today's presentation. Thank you for listening and have a great day.